So I propose to open this session. Good afternoon, ladies and gentlemen. It's my honor to welcome you on behalf of Remtech Europe. Marco Falconi, thanks to whom this conference is taking place, will join us during the session. He has to attend another session at the moment. I am Christiane Vermeil. I've been working for the Swiss government and I'm the head of the section Contaminated Side at the Federal Office for the Environment. And I have the pleasure to co-chair this session this afternoon with Aldo Trezzi von Humboldt. So I open this session 14, that is a training course organized by Humboldt. And this training course is about the sustainability assessment as a tool for more sustainable and resilient remediation of soils, groundwater and sediments. And I let now the floor to Aldo Trezzi to present this session. Please, Aldo.
Thank you very much, Christiane, and good afternoon to everybody. And thank you for participating to this Remtech Europe training session on sustainable remediation tools organized by Rumble. And the workshop will take about 2 hours, and the agenda will cover the following topics. Well, at the beginning, we will have the introduction that will be carried out by Mark Nielsen. Then Jarno Leitinen will present various types of tools for sustainable remediation assessment. Then our colleague Richard Bewley will present a worked example using Sure by Rumble, the Rumble new web-based application to support sustainable remediation assessment. Then Gitte Lemming Sodersgaard will give a case example of Sure by Rumble. Then Christopher Ritchie will give us a global view and information in relation to the upcoming ITRC guidance. Then we will have the discussion session who will be chaired by Christiane Vermeil. And finally, Mark Nielsen will give the closing remarks. Well, an important rule of the house is that all the question, well, you can send all the question by the Zoom chat. And so we will try to answer the more technical question during the presentation also, but all the, let me say, general question will be discussed during the panel discussion session. So now Mark Nielsen can start, can launch the training. So Mark is a principal within Rumble Environment Health, and he is the chair of Rumble Global Site Solution Service Line. Mark has over 30 years of experience with site characterization and remediation with a focus on risk-based remedy analysis and remediation options. So Mark, I give you the word to you.
All right, thank you, Aldo. Good afternoon and greetings from Philadelphia. We do appreciate everyone's attendance and participation in today's workshop. By way of kicking off our session, if you go back one slide, Aldo, I would begin by noting that it was recently reported in Environmental Business Journal that 5 of the top 10 environmental markets for 2021 relate to climate studies, greenhouse gas mitigation, adaptation, resilience, and renewable energy. We're certainly at a point for defining our role as practitioners involved with cleaning up contaminated sites and responding to social pressures to be sustainable and climate focused as we conduct our business. At Ramble, we do believe that sustainability and climate resiliency must be fundamental, constant drivers in our project delivery now and in the future. As Aldo introduced, today's workshop on sustainable remediation will first focus on providing an update on efforts to integrate sustainability in our remedy analysis process, introduce key sustainability metrics relevant to those remediation projects, and provide instruction on conducting a comparative analysis of competing alternative remedies using the Sure by Ramble web-based tool. We'll also discuss consideration of climate change and resiliency in our remedies as we look at long-term performance. Next slide, Aldo. We first introduced Sure by Ramble as part of the 2019 AquaCon Soil Conference in the context of natural capital and circular economy for sediment remediation projects. And then following the 2019 workshop, we continue to conduct surveys to benchmark participant understanding of sustainability concepts and applications in site remediation selection. Some of the questions we ask in our surveys is sustainable remediation a clear, well understood concept in the country or region where you're working as it relates to contaminated site remediation? Do you have access to accepted methods for conducting an evaluation of sustainability in your remedy selection process? Does your country or region have established regulatory guidance for sustainability metrics? So we have a harmonized approach. Are you seeing increasing emphasis on sustainability coming from your clients, regulatory authorities, or other public and other non-governmental stakeholders? And finally, is relative sustainability of different remedy alternatives used to evaluate and select remediation alternatives? And so here's the latest graphic showing the outcome of the survey we conducted earlier this year. On the left graphic, we have received responses providing good geographic distribution between North America, UK, Europe, and Nordics. However, as indicated on the graph on the right, more than half the respondents reported not having incorporated concepts of sustainability into a remedy assessment and selection, although less than a quarter of the respondents noted including some form of sustainability concepts into their analysis. If you go to the next slide, we did sort of look deeper into those responses, and we found sort of this equal distribution when we ask practitioners, what do they consider the definition of sustainability to be as they apply that in remedy analysis. So about a little bit more than a third seem to capture a full range of optimization of environmental, social, and economic benefits that really is aligned with what we mean by sustainability, looking at those three main factors. However, you'll see that equal groups looked at it in much more limited scale, as application of green remediation technologies, or just looking at long-lasting, durable design, which we may call more resilience than sustainability, or just looking at the carbon and greenhouse gas footprint. So, a few comments we also received from participants in the survey is, this expectation that there's a need for education of all stakeholders, practitioners, regulators, in particular, the need to address the perspective that sustainability is often just a window dressing in our selection process. It has to become more central to how we evaluate our alternatives. In addition, we need more regulatory drivers regarding sustainability, that this becomes a common element and expectation on our projects. And we need a regulatory focus on the regulatory focus tends to be on chemistry and risk, while the perception is responsible parties focus more on cost and risk management, and perhaps all parties in that equation lose sight of the sustainable solutions. So, and then finally, there's a limited understanding of how to apply sustainability metrics to remediation projects. For example, should they focus on CO2 emissions, habitat loss, habitat creation, biodiversity, or other metrics, or all metrics? So there's there's education really necessary here. And so these comments emphasize our ability to impact sustainability of our remedy decisions if we continue to educate and inform all parties. Next slide, Aldo. Sort of a corollary to that analysis was to gain some insights regarding consideration of climate resiliency as we look at our remedies. What these graphics indicate that on the left, we are starting to see a move from sustainability not being considered and shifting over. So there's sort of a range of application in remedy analysis. This is probably different than we were several years ago, where this was a left shifted graph. What you'll see on the right, though, is are you considering climate change truly in terms of the resiliency of your remedy? And you'll see we're still sort of left biased that it's not really being considered. So we have to start thinking about how climate change, sea level rise, change in water supply, groundwater, hydraulics may influence or impact the remedies we're building today. So in summary, the three key points or takeaways: we need to increase education of the benefits of considering sustainability and resiliency in our remedy decision making. Next, we have to have a common language when it comes to discussing these concepts. And third, we should have a formal framework for conducting and presenting the results of such an evaluation. So with these objectives in mind, we've developed an online tool that will be introduced today for conducting semi-quantitative remedy evaluations, and Richard and Jarno will walk you through those in detail today. So from here, I'll turn it back to Aldo and Jarno for introduction to sustainability. Yeah. And thank you again for participating.
Well, Mark, thank you. Thank you very much for this nice introduction. You face the chain properly. And so now we can move with the first presentation from Jarno. The presentation is related to sustainability assessment for remediation. Well, Jarno is a senior advisor in Tampere office in Finland from Rumble. And Jarno has over 20 years of experience in soil and groundwater contamination, with a strong emphasis on in-situ remediation and in general in sustainable remediation. And Jarno is the one who started the development of the Sure by Rumble, our new tool for sustainable remediation. Okay, we can start with the presentation.
Good afternoon, everyone. My name is Jarno Laitinen. I'm working as a senior advisor for Rumble in Finland. I'm here to present to you today about sustainability assessment in sustainable remediation. Let's start off with definitions. Based on ISO standard, sustainable remediation is the elimination and/or control of unacceptable risks in a safe and timely manner while optimizing the environmental, social, and economic value of the work. This brings us to the problem. To optimize the environmental, social, and economic value of remediation, we must be able to assess and affect sustainability at all stages of a remediation project. To do this, we need a solution and a framework that allows for case-specific assessments of conflicting sustainability objectives for the various stages, and one solution is sustainability assessment. Looking at the history, sustainability assessment has its roots in impact assessment. Environmental impact assessment started off as early in the 1970s in the US. And since that, under the umbrella of EIA, several other forms have been developed since, namely social impact assessment and health impact assessment. In the late 1980s, the environmental impact assessment was broadened to a concept of strategic environmental assessment that was more targeted on the policy and program level of impact assessment. And now, since the early 2000s, there's been bubbling under a third generation of impact assessments called the sustainability assessment. This is a distinct form of impact assessment with various approaches, and we'll look into that more deeply in the following slides. Let's have a quick comparison of the key impact assessment methodologies. Environmental impact assessment is an assessment of the environmental consequences of an individual project prior to the decision to move forward with the proposed action. The strategic environmental assessment is, on the other hand, a systematic decision support process aiming to ensure that environmental aspects are considered effectively in a policy or a program making. For sustainability assessment, it's not enough thought to assess, but there should be an emphasis on promoting sustainability. Therefore, the sustainability assessment should be seen as a systematic process to promote sustainability development by assessing the extent to which the policy, program, or product will help to achieve the relevant environmental, economic, and social objectives. So whereas the EIA is aimed at the project level with a narrow environmental focus, the SEA is aimed at the policy and program level with an environmental focus with some aspects of sustainability included. The sustainability assessment is aimed at any decision, any level of decision making with a broad sustainability focus. State-of-the-art sustainability assessment places emphasis on delivering positive net sustainability gains now and into the future. This is in line with the Brundtland's definition of sustainable development and its long-term view. Minimizing of negative effects, it's not enough. Assessment must encourage positive steps towards greater community and ecological sustainability, towards a future that's more viable, pleasant, and secure. And then what constitutes a sustainability in the context of an individual sustainability needs to be determined on a case-by-case basis, and there needs to be room for debate. A sustainability assessment can likewise be directed to any type of decision making, can take many forms, and is fundamentally pluralistic. It accounts for people with different beliefs, backgrounds, and lifestyles participating in the dialogue as multiple stakeholders with multiple views. And each sustainability assessment process should be tailor-made for the context and the assessment it's meant for. So reflecting on the state-of-the-art thinking, sustainability assessment should take a systems rather than a three-pillar approach, seeking to deliver sustainability gains through greater system health and resilience. This is a move away from the weak sustainability, because merely considering the three pillars of sustainable development encourages trade-offs between the pillars. A stronger view of sustainability acknowledges that economy, society, and environment all form a nested system that is interconnected and ultimately functions as one. To prepare a sustainability assessment, various tools can be used. The key purpose of these tools is to help understand the system and present the information of the assessment in a way that can assist the decision makers throughout the process. And most frequently used ones are in our domain on environmental remediation, the environmental risk assessment, and a few others to name: life cycle assessment, cost-benefit analysis, and now in the context of sustainability assessment, more and more traction is gained by the multi-criteria analysis and the net environmental benefit analysis. Let's have a look at the common tools for sustainability assessment. Life cycle assessment is a method for assessing the environmental impacts associated with the whole life cycle of a product or a service. The limitations of LCA is that it focuses solely on the ecological aspects of sustainability and not on the economical or social aspects. The cost-benefit analysis is a method for estimating the strengths and weaknesses of a policy or investment alternatives. The CBA is based fully on monetizing decisions, and without using weights, the CPA, it's not the case that everyone matters the same, but rather that some people who value less money receive higher weights. One reason for this is that high-income people, one monetary unit is worth less relative to low-income people, and they are more willing to give up one unit in order to make a change that is favorable for them. This can have a clear impact for issues such as land quality, recreational use, or conservation. Multi-criteria analysis is, on the other hand, a systematic approach for supporting complex decisions from politics and business with multiple predetermined and potentially conflicting objectives and criteria. MCA, on the other hand, does not give a quantifiable metrics as the two above, because often there is not a unique optimal solution for such problems, and it's necessary to use decision makers' preferences to differentiate between solutions. So LCA is a quantitative tool based on material and energy. CBA is a comparative method based on monetizing decisions, and MCA is a sorting and ranking tool using semi-quantitative, qualitative or quantitative data. So how does this then relate to contaminated site remediation, and why does sustainable remediation matter? If we look at a graph where we have a contaminated site, the contamination poses an impact within that site, and as we start remediating that, the impact within the site is being reduced. And when we at certain time reach the compliance level, the impact is very small anymore. But as we remediate, we are at the same time inducing impact to the economy, to the environment, and to the society. And when we sum up the contamination with the sustainability impact, we reach a concept called sum impact. And what sustainable remediation tries to explain is that even though when we remediate the site and reduce the contamination impact within that site, we only create very small sustainability impacts because of the effects that we have on the society, environment, and economy. So what sustainable remediation tries to help us conceive is that if we find this kind of a way of optimizing the impacts that we gain from the remediation with the impacts that are caused due to the activities, we can reach this optimum point where we have the maximum sustainability gains. But still, often we are looking to remediate a last thread of contamination. That means that we try to remove everything, and at that case, even though we have very marginal gains to achieve in terms of the impact at site level, but we are already introducing significant negative sustainability impacts to the society. So if you want to apply this kind of a sustainability assessment in remediation, where should you place this kind of a process? Of course, the right answer is throughout the remediation project, but a key place where to place it is at the planning stages. So once you've identified, based on the risk assessment, that there is a need to remediate, and you're planning the risk management strategy, you've identified the suitable remedial options, and after that you start looking into the impacts of those options, not only on the contamination, but also on the sustainability as a broad. And this is the step where you conduct your sustainability assessment, and this is the step where you define whether the solution is sustainable. So what are the elements of a sustainable remediation assessment? There is a lot of existing good literature on research and roadmaps, and there is an ISO standard and ASTM standards that give good additional information. And the commonalities of all of these include, as well as what was presented earlier in this presentation, is that sustainability assessment can and should be industry specific. It should be systematic and process-based. It should introduce a life cycle approach and move along with tiered evaluations. It's pluralistic and it should acknowledge stakeholders, and it should have a balanced consideration between sustainability and other criteria. And a key element in sustainability assessment, as in sustainable remediation overall, that we should move from actual assessment to active sustainability advancing. As pointed out in the previous slide, a tiered approach should be applied to sustainability assessment. This means that the right level of analysis should be applied at the appropriate stages. In the first stage of a project, quantitative or a semi-qualitative screening is often sufficient to identify the key sustainability indicators that can potentially have impact on a remediation project. Various approaches can be used, such as checklists, matrices, or the Sure by Ramboll tool, which will be showcased today. Once the key criteria have been identified, and if need be, these can be analyzed more in depth using the necessary quantitative tools. For economic questions, for example, CBA, for environment, LCA, or environmental risk assessment, and for example, the social questions, the social impact assessment. And when the key sustainability criteria have been identified and quantified, it's time to move to the last step in sustainability assessment, which is positively enhancing the sustainability through engineering and project design. How does a sustainability assessment look like in a remediation project? In a tool developed by Ramboll called Sure by Ramboll, we've developed a list of 100+ individual indicators that are divided into 20+ categories in the environmental, social, and economic domains. The aim of these indicators is to describe various metrics that can be used to assess against sustainability objectives in a project. An indicator is something that can be individually defined and measured and used to describe a property of the option under assessment. An example indicator for the environmental domain could be, for example, greenhouse gas emissions, soil consumption, or landscape effects. Likewise, for the social and economic domains, examples could be risks to site workers or ability to respond to changing conditions. The indicators used in Sure by Ramboll have been developed based on publicly available or peer-reviewed literature and detailed by our professionals from related disciplines. The indicators are also connected with the related United Nations Sustainable Development Goals to allow for tracking and benchmarking our progress in relation to commonly agreed objectives. Sustainable remediation is about making sustainable decisions, and sustainability assessment is a tool for such decision making. As noted in this presentation, sustainability can have multiple definitions that are case dependent, and because of its multi-stakeholder nature, also multiple potentially conflicting objectives. In a remediation project, one key decision point is the selection of the right remediation strategy that balances the benefits from reduction of risks while optimizing the environmental, social, and economic value of remediation. It's always important to think about the sustainability objectives in a project, whether they're internal or, for example, based on the UN SDGs, and then assess how relevant criteria are met. Then to use this information to either analyze the sustainability impacts in a more in-depth quantitative manner or to directly use it in planning a more sustainable project. With these words, I want to thank you all for listening.
Thank you very much, Jarno, for your presentation. Now we will have a worked example of a sustainability assessment of 3 remedial options by using Sure by Ramboll. So the presentation will be given by Richard Bewley, who is a senior managing consultant in the Manchester, UK office in Ramboll. And Richard has over 45 years of experience in soil and groundwater contamination. very extensive experience, and so his experience include also application of sustainability principle to soil and groundwater remediation, and for which he provides support to clients across Europe. Okay, so Richard, you can start. Thank you.
In this part of the workshop, we're going to introduce our in-house tool, SURE, which we use to assess the sustainability of a select number of options for remediation. We shall illustrate its application to a made-up example of a simple remedial options sustainability appraisal. SURE is going to be made available to everyone online free of charge in a few weeks' time. And this example will illustrate the overall procedure and the thought process needed to conduct the assessment. So this is SURE, a means of assessing sustainability of remedial options, and in so doing, engaging with stakeholders and reporting the decision-making in a transparent manner. SURE by Ramboll is based on the state of a practice for sustainable remediation methodology generally developed within SURF UK and is purposefully aligned with SURF UK guidance and the ISO 18504 standard. Here we have an overview of a SURE project lifecycle. We log in and create a new project. We frame the project and then select the indicators by which we are going to assess the options, the ones that we have pre-selected for comparison. We then assess these options and generate a report. The iterative nature of SURE then allows stakeholders to comment on the assessment and pass it back to the assessor, who can then make any appropriate revisions and finally issue as a PDF report. So let's look at how we can apply SURE to a worked example. The example is purely fictitious, so any resemblance to any contaminated site, current or historic, is of course purely coincidental. Our client, Green Site Developments, is looking to develop land that was previously part of a large fuel depot. Some of this depot had previously been remediated, and this had been done in a manner that had caused a lot of bad press in relation to odour, dust and noise. In our example, there's just one area of contamination, heavily impacted soil in the smear zone. No more than a thin film of free product, L-napple, is present, but there are elevated dissolved phase hydrocarbons in groundwater. The main receptor is a stream, some 200 meters distant. Three options are selected for assessment: excavation and disposal of smear zone soil, then pumping out the contaminated groundwater and reinstating with clean backfill, including an oxygen release compound for polishing. We call this excavation. We've estimated this to cost about €350,000, but the remedial targets are easily achievable. Number 2 is In-Situ chemical oxidation, ISCO. 3 campaigns of sodium persulfate injection with a final round of oxygen release compound for facilitating enhanced biodegradation of what's left. The cost estimate here is €200,000. The remedial targets are reasonably achievable, although there are bands of silty or clay soils that may reduce the effectiveness of the injection process. Finally, monitored natural attenuation, MNA, using an existing well network, but with a 5 to 10 year lifespan. This costs around €100,000, but the achievability of a target is less certain. Let's look at the stakeholders' perspectives. First of all, the client. Client has an eye on costs naturally, but also wants the issue dealt with in its entirety, fully completed and verified. Have a highly visible corporate image with respect to sustainability. They previously experienced adverse issues and they want to get it right this time. What about the local residents and neighbours? Well, the previous remediation close by has left some bad memories. They're not entirely convinced over no human health risks as have been identified. They want to see it dealt with effectively and safely and out of the way. Finally, the regulator. Not so much interested in how, but making sure that remedial goals and targets have been achieved, and also that there is evidence to show for it. So that's our case study. Well, let's start off as we would do when we access Shore. First thing to do is to sign up if we don't have an account already. So when Shore opens up, this is what we see as the home page. We click Menu on the left-hand side. And as you see here, we can manage existing projects. We can review a project if we've been assigned as a reviewer, or in our case, create a new project. So after clicking Create Project, we see the following. Well, first of all, we just fill in the basic details. We can now fill in the following details: the title, the address, the client name, the client address, and the representative. We then move on to project framing. Now, project framing sets out the context of a project, what we're trying to achieve. Specific points to note here can be recorded. For example, the concerns of the residents. So at the top, we've described where we are in the project life cycle, what's been done already, what the remediation is meant to achieve and why, what the sustainability assessment itself is intended to do, and any points of note. So again, the local residents' concerns could be mentioned here. We can list and then describe our 3 options. We also introduce project stakeholders, some of whom may be having a direct input into the assessment as reviewers. We state what approach we intend to carry out this assessment. In our case, it's semi-quantitative, and how we shall compare. In our example, we shall score on a scale of 1 to 5. Boundary conditions are also defined. For spatial boundary, most assessments will probably be global. After all, the very nature of sustainability is to consider our impact on the global ecosystem, greenhouse gas emissions being the obvious example. But there may be instances where circumstances demand, say, a more focused outlook. Likewise, we normally look to the future generations when considering temporal boundary. But again, recognize that there may be projects where we just want to judge effects over a more limited timescale. Life cycle considerations are also important. Where do we draw the line? In our example, we are looking to include assessments of materials and reagents that are going to be used in the options being considered. But we're not going to be looking at the processes that are used in the manufacture and equipment. So we're not going to worry about how much greenhouse gas emissions were involved in the making of a backhoe or a lorry, for example. Once we've framed the project, the assessment itself can begin. Now, when we open the assessment page, we firstly see on the left-hand side the 3 domains of sustainability. That is environment, society, economy. And our 3 listed options are presented in columns along the top. The first thing we do is to choose the indicators by which we are going to assess the options. We do this by clicking Select Template. After clicking Select Template, we are then presented with just over 70 indicators which are taken from the updated SURF UK listing that was published earlier. Within each domain, these 70 or so indicators are grouped into the same headline categories as are used by SURF UK. On this side, we see the 5 environmental categories on the left-hand side: emissions to air, soil and ground conditions, groundwater and surface water, etc. Now, to keep things simple for this example, we are just going to pick 3, which we do by checking the tick box for each one. In this case, greenhouse gases, legally binding objectives, and primary resources and waste. Similarly, this is for the society domain. And finally, for economy. Here we've ticked direct cost benefits, corporate reputation, and duration, timing of benefits. So when we've done that, we can then save the template under our chosen name, and this returns us to the assessment page. Having chosen our indicators, we then weight them according to their relative importance on a scale of 1 to 5, 5 being the most important. So here we've opened up the categories to reveal the indicators. For example, for category emissions to air, we've selected greenhouse gases. Now, if you click the question mark symbol next to greenhouse gases, this will provide us with more details regarding the indicator in question to help us decide its importance to the project. We can also add a comment to justify the weighting if required, as shown here. So in this case, greenhouse gases gets a 5, as does legally binding objectives, and primary resource and waste a 1. We put there a comment as to why we have given greenhouse gases a 5, namely the corporate goal on global carbon dioxide reduction. Similarly for the domain of society, here we've assigned a 3 to direct risks arising from human health and safety, a 5 for nuisance issues, and a 3 for uncertainty and evidence. Finally, economy. Cost benefits receive a 5 with an appropriate comment, as you can see there. Primary economic consideration. Corporate reputation, duration, timing of benefits, each receiving a 3. Once we've done the indicator weightings, we can then proceed to assess the options indicator by indicator. In each case, we start by clicking the question mark symbol next to the indicator name, in this case greenhouse gases, firstly to remind ourselves what it refers to, but more importantly for information on how we shall compare the options for this particular indicator according to SURF UK guidance. Finally, the same information pop-up tells us which United Nations Sustainable Development Goals each indicator is linked to. In this case, number 11, Sustainable Cities and Communities, number 12, Sustainable Consumption and Production, and number 13, Climate Action. This is based on the linkages that have been defined by SURF UK in the 2020 guidance. We can now assess and score the options on a comparative basis. It's important here to justify the score so we can add text as necessary. As mentioned in the framing, we will be using a 1 to 5 scale for the weightings, as for the weightings, 5 being the best. We can assign equal scores if differences are marginal, and it's important to consider proportionality when assigning scores. So for example, in this case, as we believe monitored natural attenuation is much better in terms of greenhouse gas emissions than the other two, we score it 5. And you can see that there's less differential between ISCO and excavation. On the other hand, if we now consider our second indicator, legally binding objectives, excavation and oxygenation of the groundwater offers the most complete approach, so it comes closest to achieving objectives, whereas M&A is clouded by uncertainty. The scores of 5 and 1 reflect this, with ISCO intermediately scoring a 3. And natural resources and waste, as you see there, follows a similar scoring pattern to greenhouse gas emissions. Here we see the scores for society. M&A presents much fewer direct risks and has minimal impact on the neighbourhood compared to other options. So for both these, we've scored it 5. However, it has somewhat onerous validation requirements. So it scores less well than either ESCO or excavation for which the validation procedures are relatively straightforward. As an in-situ technique, ISCO is less easy to validate than ex-situ, but easier than M&A. Hence it's scored accordingly. Finally, economy. Cost benefit can be assessed qualitatively or semi-quantitatively. In this example, excavation delivers benefits, but the cost increase for such relative to ISCO is disproportionate, even if ISCO might not achieve a degree of thoroughness. Hence, ISCO scores 5, M&A is cheaper than both, but the degree of mitigation is less, then it receives an intermediate score. Corporate reputation? Well, what might go badly wrong? Excavation has had a bad press lately, and what if M&A fails? Hence the scoring. Timing of benefit? Well, not so good for M&A. On completing this, we can then save and click Proceed to the assessment report, as you see at the bottom. SURE now provides us with a graphical summary of the outcome of the assessment, the first part of which is shown here. The pie chart on the left-hand side shows a relative weighting ascribed to the domains. In this example, it is 33.3% each. The bar chart on the right provide details of the overall scores and the individual scores for the 3 domains. ISCO comes out the best, but it's important to look at the performance in relation to the individual domains, which SURE allows you to do in a very easy manner. Not a great deal of difference there between environment, shown in green, M&A coming out slightly better, but performing much better than the other two socially, blue, where excavation has done less well. While ISCO comes out scoring the best in the economy domain, which you can see in red, with M&A performing poorly. Scoring per indicator category is also provided, as you can see here. So starting in the top left, we have the environment categories, emissions to air in green, groundwater in orange, and natural resource in blue. So we see here, for example, how well M&A is performing regarding air emissions. Top right is social sustainability. Green, human health and safety, where M&A performs well, as with neighborhood and locality, which is shown in orange, whereas excavation does best with uncertainty and evidence, which is shown in blue. Finally, if you now look on the bottom left to see the economy domain, excavation does well for lifespan and flexibility, shown in blue, but ISCO does much better in terms of costs and benefits, both in green and orange, respectively, and as you can see, a relatively poor performance for both of these in the case of M&A. Well, we do, of course, have the ability to go back and amend the assessment, particularly if we're looking at the sensitivity. And when we are happy with it, we may, as an option, then send it to review, either by an internal or an external stakeholder. The reviewer or stakeholder is invited by email to review the assessment and then can make comments, as shown here on the right-hand side, for example. The reviewer could choose to accept the assessment if no changes are needed, or reject it if any changes are necessary. The assessor then logs in again and sees the reviewer's comments, as you can see here on the right as previously, but with the name of the reviewer and the date of the comment also provided. The assessor can make any changes before sending it back to the reviewer with a revised version. Once final approval is granted, the report can be published in full. The report can be as long or as short as required. There are 2 default inclusions, but the rest are selected by ticking the boxes as shown here. Now, all of the previous charts I showed earlier can be included in the final report. We haven't time to look at a report in its entirety, but here are some extracts. The top row of pie charts show how each option scores according to the three domains. And then in the middle row, for performance according to each of the three indicator categories, as per this example, within each domain. Finally, another feature of SURE is to enable a comparison of options according to their contribution to each of the 17 UN SDGs, as shown by the multicolored pie charts on the bottom row, each segment representing a particular UN Sustainable Development Goal. We have basis on the linkages that were constructed between each of the 70 or so individual indicators and the relevant UN SDGs in the revised indicator listing from 2020. SURE has taken these linkages and automatically mapped the relevant indicators and option performance in relation to which onto each SDG for which a linkage exists. In our case, we've only used 9 of the 70 or so indicators that exist, so we have to treat the output accordingly. But hopefully, the following provides illustration. Here is the first of 3 pairwise comparisons of impact on UN SDGs, starting with excavation on the left versus ISCO on the right. So if we treat this as a clock face, then the UN SDGs run clockwise, starting with number 1, poverty, in the 12 o'clock position, and ending with number 17, strengthen implementation and partnership. If, for example, you look at the 2 o'clock position, we see good health and well-being, that's UN SDG number 3, for which both options contribute similarly. If we now look at the 6 o'clock position, we have an orange 9, which is build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation, for which ISCO delivers greater benefits. Number 13, climate action, is dark green at 9 o'clock, for which ISCO performs better. On the other hand, number 15, life on land, which relates to the protection of terrestrial ecosystems, biodiversity, and so on, at 10 o'clock, is best served by excavation. Next, we have excavation on the left versus M&A on the right. Now this time you see the stronger contribution to mitigation of climate change by M&A, dark green 9 o'clock, but note that for number 6, clean water and sanitation, blue at around 4 o'clock, excavation and oxygenation makes a better contribution by providing a more thorough cleanup. In the final pairwise comparison, we examine ISCO versus M&A. You can see M&A performing best again with number 13, climate action, but ISCO doing best with number 6, clean water and sanitation. That's blue at 4 o'clock. And also on number 9 in the 6 o'clock position, build a resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. Well, as mentioned, because we've just selected 9 indicators out of more than 70, this will not give a particularly realistic depiction of the impact on UN SDGs. But hopefully this example allows you to see how SURE can be brought to bear for such purpose and enables a considered opinion to be reached on the best option going forward in terms of sustainability, i.e. not just relying on a single score. So to sum up, we have a tool, SURE, for assessing the sustainability of remedial options, and in so doing, engaging with stakeholders and reporting for decision-making in a sustainable and transparent manner. It is designed with a wide range of end users in mind, indeed anyone working with contaminated land. Simplicity is the key. We want to avoid complexity in how we communicate environmental, social, and economic impacts in projects. Also, sustainability assessments must by their very nature be transparent and open to interrogation. By recording the decision-making process and identifying the driving factors, SURE fulfills this requirement. Our tool also facilitates external reviews, client, regulatory, stakeholder, so we can evaluate the outcome based on different perspectives. Its output provides efficient, acceptable, and sustainable solutions, and it is compliant with ISO 18504, ASTM, and SURE and SURF guidance. As we've seen, it further supports the need to fulfill UN SDGs by assessing the relative contribution of different approaches. We have already employed the approach in projects across Europe, including the UK, Germany, and Scandinavia. And the final point here is arguably the most significant. Once we have completed internal review, we should be making SURE available to all practitioners free of charge. This underlines Ramboll's commitment to sustainability and our belief that it should be freely available for everyone. Thank you.
Thank you very much, Richard, for your very, very clear presentation. Now I think that all the participants of this training have the basic knowledge on how to use SURE by Ramboll tool. Well, Richard and Jarno worked a lot in order to develop SURE by Ramboll. We thank them for their commitment. Okay, so I think that we can move on with the next presentation. That is a case example, comparison of plume stop and pump and treat. Will be given by Gitte Lemmy Sondersgaard. Gitte is a senior consultant in Ramboll, Denmark. Gitte has over 16 years of experience in soil and groundwater contamination, and she's specialized in risk assessment and sustainability assessment. Okay, I think that we can move.
I'm Gitte Lemming Søndergaard, and I would like to present a case study where the SURE tool was applied for a sustainability comparison of two different remediation technologies for a contaminated site. A bit about the background and the objective of the case study. This project was financed by the Danish EPA and co-financed by the Ramboll Fund for Knowledge and Innovation. And as part of this project, we applied a preliminary version of the SURE tool, a beta version, to compare the sustainability of two remediation options for a case study. And this project involved 3 Danish regions who participated in meetings and workshops and gave valuable inputs both to the selection of sustainability indicators and also to the assessment of indicators. The project is described in the report seen here, which is soon to be published by the Danish EPA and can be accessed via the website. And this report describes both the methodology for the assessment and also the application to the case study. The case study site is located in an industrial area in the capital region of Denmark, and it's the capital region that is responsible for remediating the site. It has hosted polystyrene production since 1962, and this has caused the contamination of the groundwater, mainly with TCE, and this has given a 30-meter wide plume in the groundwater. The aim of remediation at this site is the groundwater plume and to contain this plume for a period of 30 years, so to prevent further spreading of TCE and metabolites above threshold values in the groundwater. And 2 remediation options was compared for the site. The first is a more traditional method using pump and treat, so to create a hydraulic barrier in the groundwater to prevent spreading. Second option is called plume stop, and this is a more novel technology, creating a sorption and degradation barrier in the groundwater by adding plume stop, a liquefied activated carbon, together with other amendments, which are electron donors and specific degrader organisms, to create this sorption and degradation barrier. In order to compare the solutions, we did a description and a remedial design to assess amounts of materials and energy. The pump and treat solution will require establishment of a pumping and monitoring wells and an on-site treatment facility with both sand filters and activated carbon filters. So this method represents a more active remediation option, with active remediation taking place throughout the 30 years. In comparison, the plume stop method will require the injection of liquid activated carbon, the electron donor and degrader bacteria along a transect consisting of 18 injection points. The liquid activated carbon only needs to be injected once, but the donor and the bacteria is re-injected every 5 years. And this represents a more passive remediation system with no on-site treatment facility. This table is a comparison of some of the amounts of materials and energy used for the two technologies, as well as the cost. And it's worth to note that very large amounts of activated carbon is used in the pumping scenario, 125 tons, whereas the amounts injected for the plume stop method is much smaller, for example, around 500 kilograms of activated carbon. Furthermore, the pump and treat uses quite a large amount of energy for this continued pumping, and it's also the most costly method. It costs just below 16 million Danish kroner, whereas the plume stop method will be around 6.5 million Danish kroner. We did a first sustainability comparison using 17 selected indicators divided between the environmental, social and economic domains. So we had 6 environmental indicators, 5 social and 6 economic. And note that we used the beta version, so a preliminary version of the SURE tool. That's why it looks a little bit different than what you saw previously. In all the assessments that we did, we chose to do an equal weighting of the 3 domains. So they were each weighted 33%. Then we assessed all the indicators on a scale from 1 to 5, where 5 is the best possible score and 1 is the worst score. Let's look at some of the environmental indicators. So pump and treat was given a score of 2 in the greenhouse gas emissions, since it has the highest greenhouse gas emissions due to the continuous pumping and also the large amounts of activated carbon which needs production. Then regarding the changes in groundwater and surface water quality, the best score was given to the pump and treat options, whereas a score of 4 was given to plume stop, because here there is a risk that there'll be leaching of degradation products for a period until the barrier is properly constructed. Regarding raw materials, the best score of 4 is given to plume stop, since it has rather small material use consumption, whereas pump and treat is given a score of 2, mainly due to this very large coal consumption. And the activated coal also generates a large amount of activated carbon waste. So here a score of 3 is given to pump and treat, whereas a better score of 5 was given to the plume stop method due to only small amounts of waste. Let's look at some of the social indicators in the assessment. So we found that the social impacts were generally low and relatively similar for the two options. However, we did assess that there may be some ethical considerations related to the plume stop method, because here we inject something to the subsurface and it contains small amounts of unknown additives, a polymer, which is proprietary information. Regarding pump and treat, it's a more active remediation method and it requires permanent installations on the site for water treatment for the 30 years. So there will be a larger level of nuisance to people and industry on the site. Regarding the economic indicators, pump and treat is more costly and therefore it has a low score in the direct economic costs and benefits, but at the same time it's also a well-known technology and the uncertainty related to the technological performance is relatively low for this technology. And in comparison, plume stop, it's a newer technology. It has not been applied as much as pump and treat, and there's a larger uncertainty related to the performance of this technology. So it has a worse score here in the uncertainty. Based on the assigned scores and weights to each indicator, the tool calculates this sustainability impact score, which is a weighted sum of each score and the weight. And we see in this case, plume stop has a higher score, meaning that it has the best sustainability profile, and plume stop has the lowest overall score. And in this case, we see that this is mainly due to a lower environmental score. The tool also gives you an overview of the assessed indicators and the associated weighted scores. And this list can give you a good overview of pros and cons of each remediation method. This is from the beta version. In the online tool it looks a bit different, but it's still very useful. Secondly, we did a tier 2 assessment, and the main difference here is that we extended the number of indicators. So now we had 9 environmental indicators, 5 social indicators, and 9 economic indicators. Again, we weighted each domain equally. And then we applied a life cycle assessment to assess more in detail some of these environmental indicators, such as greenhouse gas emission, acidifying emissions, local air pollution, hazardous waste production, and the use of fossil energy. And here on the figures to the right, you see the outcome of the life cycle assessment, and here it's pretty clear that for all these categories, we found the highest impact from the pump and treat technology. And this was used to have a better basing to do the scoring of some of the environmental impacts. The overall result of the tier 2 assessment is seen here on the bottom, including the life cycle assessment results and the additional indicators. And again, we see that it's the plume stop method which has the highest overall sustainability score, and therefore the best sustainability profile. And we also see now that including the life cycle assessment results, the pump and treat option has a significantly lower environmental score, as it performs even worse in these indicators. So this gives a more clear outcome with a larger difference in the total sustainability score of each option. some conclusions based on this project. So regarding the sustainability comparison, we found that plume stock was assessed to be more sustainable than pump and treat, and this was mainly due to the lower environmental impacts. About the tool in general and its application, we concluded that this tool provides a good framework for giving a structured discussion about sustainability within a stakeholder group or within an assessment group. So it ensures that you go through all important aspects of sustainability and that you're not only focusing on selected issues like environmental indicators, for example. And we also found that it's very good as a decision support tool. So it can support a decision, it cannot take the decision. And that the outcome is always dependent on which weighting factors that are applied. And we recommend to always show the results also with an equal weighting, so you can see the difference and the significance of using other weighting factors. And that's all about this case study. Thank you for your attention.
So thank you very much, Gitte, for this presentation. So who show us a real example, and so and also discussion that Rumble had together with the various stakeholders. So now we can go on with the last presentation that is related to will give us a global view of the sustainable remediation and also some information about the upcoming ITRC guidance. So the presentation will be given by Christopher Ritchie. Christopher is a senior managing consultant at the Emeryville, California office of Rumble, and he has over 15 years of experience in site investigation and remediation with focus on sustainable and resilient remediation solution. So we can start with the Christopher presentation.
Good afternoon from San Francisco, California. My name is Christopher Ritchie. I'm a senior environmental engineer with Rumble, and I'm here to talk to you briefly about integrating resiliency into existing sustainability frameworks, focusing on environmental remediation. Very recently, the Interstate Technology and Regulatory Council, ITRC, a US-based, state-led coalition, published guidance on this topic, which practitioners of sustainable and resilient remediation around the globe will likely want to be aware of. Here is an overview of this brief 10-minute introductory session. It is now clear that the steadily increasing economic, environmental, and social losses from natural disasters, and the awareness of the potential effects of catastrophic events on vulnerable infrastructure, require more consistently applied policies and procedures to implement and measure resiliency. Integrating resiliency with sustainable planning and management is expected to minimize conflicts and maximize synergies when compared with separate implementation strategies. However, it can be complicated in practice. The Interstate Technology and Regulatory Council, ITRC, is a coalition working to reduce barriers to the use of innovative remediation approaches and technologies. ITRC formed a sustainable resilient remediation team in 2019 to develop guidance to help integrate sustainability and resiliency practices into site cleanups. The SRR guidance, published in April 2021, offers insights for similar initiatives elsewhere in the world. This slide presents the case for resiliency with some numbers from the US. In 2019, the US Government Accountability Office published a report indicating that 60% of environmental cleanup sites are in areas that may be impacted by flooding, storm surge, wildfires, and/or sea level rise. Moreover, a 2018 report by the Sustainable Remediation Forum found that extreme weather events can undermine the effectiveness of environmental remediation and can also impact contaminant toxicity, exposure, organism sensitivity, fate and transport, and long-term operations, management, and stewardship of remediation sites. In the US, nearly 2 million people, the majority in low-income communities, live within 1 mile of one of 327 Superfund sites in areas prone to flooding or vulnerable to sea level rise. Moreover,
Contiene work in progress, coping costante, stiamo facendo
Finally, a recent study of US government projects found that hazard mitigation funding can save the United States $6 in future disaster costs for every $1 spent on hazard mitigation. Clearly, there is growing evidence that resiliency measures are needed for environmental cleanup sites, and investments in resiliency will actually have favorable economic returns. How one defines sustainability and resiliency are important because the definitions vary widely depending on the context. In the context of environmental remediation, one can think of it this way. Sustainability is about the remedy having low impact on the environment, while resiliency is about the environment having low impact on the remedy. In truth, it's not that simple. And in existing literature, there has been little consensus on the relationship between sustainability and resiliency and how they were put into practice. There are many similarities between the concepts of sustainability and resiliency, and they are often used without clear distinction in meaning and purpose for a variety of applications. One similarity is that sustainability and resiliency both refer to the state of a system over time, focusing on the persistence of functionality and overall benefits of that system under normal operating conditions and in response to disturbances. As such, both sustainability and resiliency are considered for the entirety of the system over its full lifespan. Therefore, time and scale are critical factors when developing strategies and objectives for each. It logically follows that while endeavors to implement resilience and sustainability are useful in all systems, they are critically important for large-scale, long lifespan systems, in which resources must be carefully allocated, and loss of functionality would have significant adverse effects. Clearly, a remedy that is not resilient can impact the environment around it. So we contend that a remedy that is not resilient cannot be sustainable. Should resiliency be considered an element of sustainability or a separate consideration? It seems like it should, but the existing literature shows otherwise. As a civil engineer myself, I first looked into the state of the practice within civil infrastructure. Here, separate implementations of sustainability and resilience are prevalent. For example, consider construction guidelines. Separate from resilience are sustainable building codes. For example, the Building Code of Australia, sustainable policy regulations, for example, Singapore's Building Control Act, and voluntary certification programs, for example, Building Research Establishment Environmental Assessment, BREEAM in England, the Leadership in Energy and Environmental Design, LEED, in the US, Energy Star, also in the US, the Building Housing Energy Efficiency Labeling System in Japan. There are also public outreach campaigns, training programs, all focused on sustainability and resiliency separately and distinctly. As a specific example of the distinctly separate implementation of sustainability and resiliency in the US, the US Resiliency Council, a nonprofit organization formed by structural engineers, was founded specifically to do for resilient design what the US Green Building Council had done for sustainable design through its LEED building rating system. However, the reason for the disparate implementations of sustainability and resiliency in building construction likely has less to do with the fundamental incompatibility of the two concepts, but rather because sustainability was adopted into civil infrastructure policies and standards prior to resilience being identified widely as a critical priority. Integrating resiliency with sustainability planning, management, and execution in the context of environmental remediation is expected to minimize conflicts and maximize synergies when compared with separate implementation strategies. The Interstate Technology and Regulatory Council concluded that an integrated approach was not just beneficial, but essential. They stated, To be truly sustainable, a remedy must maintain functionality for the duration of its design life, and do so by being resilient to extreme events and changing conditions. The interconnectedness of sustainability and resiliency, particularly as they relate to the cleanup of contaminated sites, reemphasizes the importance of an integrated approach. This became the guiding principle of the development of the Sustainable Resilient Remediation Guidance. The Interstate Technology and Regulatory Council publishes guidance on a wide range of topics related to environmental remediation, including a previous guidance document focused on green and sustainable remediation, or GSR. Therefore, the goal for the Sustainable Resilient Remediation team was to update the existing guidance and integrate resiliency comprehensively into the existing GSR framework. The overall objective of the Sustainable Resilient Remediation Guidance is to provide resources for regulators, stakeholders, consultants, and responsible parties to help them integrate sustainability and resiliency practices into their own specific remediation projects in ways that are relevant and valuable to them. The Sustainable Resilient Remediation Guidance was just published in April 2021 as an interactive web-based document. It's freely available at the website shown on the screen. The contents of the guidance are comprehensive and listed on the right side of the screen, while the heart of the guidance is the section covering integration of resiliency and sustainability into the remedial project lifecycle. There is information and resources for a variety of users. Training webinars are planned to start in July 2021 and then scheduled quarterly thereafter. I urge you to explore the guidance and see what may be meaningful to you and your projects. While it is focused on the US, I think that the guidance provides insights for how resiliency can, and in my opinion, should be integrated within existing sustainability remediation frameworks. I'll leave you with some final thoughts for your consideration. While we know hazardous waste sites are widespread, and along with all facilities operating on decadal or indefinite timescales, are potentially vulnerable to the effects of climate change, we need better examples of intentional resiliency implementation in case studies. We also need less than perfect examples to show how partial success can be measured. Tools are available to assess vulnerability down to the facility scale, from simple climate screening to more detailed analysis, which can support adaptation planning. We do know that resiliency planning fits within established site remediation decision-making with a dynamic conceptual site model, one accounting for changing conditions being the key element. Thank you for your time and attention today. I hope this brief session generated interest in sustainable resilient remediation. I do apologize for not being available to answer questions live, but please feel free to reach out via email at the address shown on the screen if you do have questions or comments. Again, thank you and have a great rest of your day.
Well, thank you very much, Christopher, for this insight about the ITRC Sustainable and Resilient Remediation Manual. So now really we know more about these, and so we understood that the remediation to be really and truly sustainable has also to be resilient to the various effects of the climate change. Okay, so we finish our presentation well in advance and in respect to our schedule. So I think that we should start with the discussion if some questions are already there. So Christian, I give the word to you to manage the panel discussion. Thank you.
Thank you, Aldo. First, I would like to thank all the speaker for the excellent presentation, very clear, very interesting, and I'm sure that we can have now some discussion and some questions. In the chat, there are not so many questions. There was a question about the availability of the tool Sure, and the answer is in the chat. This tool Sure will be available in some days or some weeks, and the address of the internet sites where you can find this tool is available on the chat. So I think this questions is so answered. There are a lot of congratulations and thanks in the chat for the quality, the high quality of the presentation and the high quality of the tool. So I would like to say that to all the speakers. And so a question is now arrived. In Sure, how are groups of experts or stakeholders assembled to assign weights to categories and scores to indicators? I don't know, perhaps can Richard
I'd be happy to
give the answer?
Yeah, happy to give some thoughts on that. I mean, each project is specific, so there's no specific rules as to how this is done. What I would say, though, is the most value of Sure is it's when it's done collectively. So that if a group of people can prepare the responses together, then it's easier to reflect a more collective decision, reach consensus that way in the first place. But of course, the stakeholders can then be the assessment can then be sent on to other stakeholders automatically through the Sure assessment on an iterative basis. So they will see the weights. I mean, obviously, if they don't agree with the weights, then they can indicate that in their review if there's anything that's concerned. One would hope perhaps that there would be some sort of consultation, particularly with some of the key stakeholders at the beginning by the assessors to get a handle, get a view on where the stakeholders' concerns lie, so that should hopefully align with the stakeholders in the first place. But obviously there will be differences of opinion, and Sure can capture it. So there's no direct way of doing it, no set way, I should say, of doing it. But Sure, is flexible and allows all these possibilities. But I would encourage people, particularly if you've got 2 or 3 people with different expertise, different backgrounds, to actually complete the assessment together, because some can probably see some stakeholders' views more than others, and collective decisions often the best.
Thank you, Richard, for this answer and this important precisions. Another questions for you about the weight. What's the weight of the efficacy of contaminant mass removal in the sustainability assessment? For instance, excavation removes more mass in a short time than pump and treat. Is that taken into account?
Yes, I mean, if you look at the various indicators, then technical effectiveness is reflected in a number of these. I mean, what we've got to look at is the sustainability of a process. So what I would say off the top of my head on those, if you look at the fulfilling of objectives, which is one of the indicators there in the soils, for example, the ability to complete legally binding objectives. I mean, clearly, if you've got those objectives aligned with contaminant mass removal, then clearly you would weight that particular attribute a great deal more for perhaps than others. But I mean, you do that accordingly. So the indicators, and say these are based on the Surf UK ones, which Surf has put a lot of time and effort into these, and they do encompass a wide range, but you do have the ability to be able to orientate those towards your own particular project. So, you know, there's flexibility in the system. It doesn't have to be that specific. It doesn't have to be laid down. It's not laid down particularly in terms of one attribute. But, you know, if you want to align mass removal with, say, fulfillment of objectives, then I think that that technical aspect can be dealt with accordingly. Jana, I don't know if you had anything. They might want to come in. I hope that probably covers it in terms of sort of technical effectiveness.
I think your answer was very good. Thank you, Richard. I don't really have anything to add on that.
Thank you very much. Yes, and in the chat, there are also thanks and congratulations for the clear answer. And there is a separate question now. How successful has Rumble been at selling the use of Sure to customers that are accustomed to more rapid projects?
Maybe I will then take this question.
Yes.
So Sure by Rumble has now been on an internal beta for 6 months, and we are now launching it for a wider public. And our goal is to help the whole transition of the contaminated site remediation discipline to move towards more sustainable practices. So what we have been doing internally is to start implementing and applying it in any projects that we see that might be viable for remedial options appraisal or for sustainability considerations. And through this process, we've learned that quite many, in fact, most of the projects could benefit from a more broad sustainability consideration. So coming to the question, I think that one of the reasons that why we are launching the tool as an open opportunity is to allow everyone to implement themselves sustainability practices and show also the customers what kind of benefits they could gain with the use of this sustainability assessment in the projects. And it is our ambition to be using sustainability assessment as a part of remediation options assessment in most of our projects in the future. So we don't have a clear answer yet, but our hope would be that it would be mainstream.
Thank you very much. I would like to ask a complementary question now. I find your tool very, very interesting. The link with the SDGs is also very interesting. And I would like to ask, how is it possible to avoid that to avoid the risk of a sustainability assessment being misused to reduce the cost of a remediation by setting less ambitious targets? I precise perhaps my questions, but in Switzerland we use more simple tool because we don't have at the moment such a nice tool as Sure, but we have to notice sometimes that these tools are misused to give a very favorable note to a remediation project that is less expensive, but that is also less ambitious towards the environmental goal. How can you avoid that with Sure?
Well, if I will start, please fill in. I will ask my colleagues to fill in addition, but sustainable remediation should always be based on a risk assessment. So whenever we remediate, we should have some understanding that there is a risk that needs to be remediated. If there is not a risk for the remediation, then you should be always asking that whether there is actually a sustainable reason for remediating. But of course, the risk assessment often provides us also a threshold above which you have to exceed and succeed in your remediation. And it's a quite broad range with different remedial approaches that you can achieve. So often there are a number of technologies that can help achieve and exceed the threshold value, and sustainability assessment can help identify what other impacts except the risk reduction those different technologies have. So this kind of a greenwashing is of course a risk. It always is, and we should all combat not to make this sustainability considerations an opportunity for greenwashing, but instead a tool that we use when there is a risk, then we find out the best and the optimal solution for mitigating that.
Yeah, I think that what I would just add to that is that again, going back to the list of indicators that there are, I mean, human health and safety is one of the key indicator categories in the social side. And within that, there is a particular indicator that, that you can use to weight heavily for, the overall effect on human health of the remediation approach. And similarly, with groundwater and surface water, again, you can align those to the objectives of the project. So, if one is not going to be doing a good job, and I mean, anybody, I think I've just looked at the comments, somebody's brought up the question of transparency, which I think is really key to this. Anybody interrogating SURE, and hopefully, I mean, SURE is very easy to interpret. Anybody can cast their eye, any regulator, any third party, any NGO can cast their eye down those lists of indicators, could look at the weightings and say, why have you given such a low weighting to health and safety? This is key. Why have you given such a low weighting to, that's the whole point. So it is open, it allows you to challenge, and it allows people to challenge that decision-making process. And again, as somebody's voted, it's that transparency that is the key issue here.
Thank you. There is also a note in the chat that transparency is key. The key is to transparency, assess whether the added removal is justified by the added environmental, social, and economic impact. The most aggressive approach is not always the most beneficial overall. Yeah, that's a great point. I come back to other questions in the chat. One comes from Albania. Do you think we will have funds for sustainable resilient remediation? We have too many hotspots here in Albania, but in fact, there are not too many movements to find a solution. Businesses have the opportunity to use an uncontaminated site while we'll invest in resilient remediation. I don't know if there are politics in other EU states that support development when technical business idea allows in this contaminated area. That's not really a technical questions about SURE, but I don't know if the speaker have answers on or input or idea on this question.
I haven't got any specific comment on that, I'm afraid. I don't know any of the colleagues can maybe come in on that. It's an interesting point, I agree.
Maybe Aldo, do you have some thoughts about this?
So I do not have so many. Mark, probably you.
Let me maybe give some thoughts. My interpretation of this is trying to reuse or redeploy contaminated sites for economic development, so new businesses moving in. So we do have programs that are really aligned with that objective, is realizing because the cost for complete remediation, say to unrestricted use, it may not be available. There are economic limitations to achieving our best environmental restoration. However, there are means through risk analysis, risk management, where we can redeploy sites for certain industry or commercial uses and still manage those risks successfully, perhaps at a lower cost. So we're not getting full achievement of remediation. we use redevelopment as a containment of contamination, of essentially eliminating the exposure pathways that drive the risks to human health and the environment. When we do that, we have to recognize we are leaving contamination in place, and that's where resiliency then really becomes critical to consider is that containment of and isolation of contamination, preventing exposure, is that resilient enough to climate change, depending on site location, floods or et cetera, that we want to make sure it remains protective into the future. So hopefully that gives you some idea how that could be sort of managed to redeploy or reuse sites, even though we may not achieve our best restoration of those sites.
Yeah, Mark, you are right, and in this case is really important. So there are really important the results of the let me say risk analysis, and then design the new the redevelopment of the site, taking into account the results of the risk assessment and addressing properly the new use of the land based on the results of the risk assessment, and then obviously the application of the sustainable remediation appraisal. Okay.
Thank you for these inputs. There is also an interesting note in the chat about these questions, that there is a lot of European works on support and barriers to brownfields redevelopment. The sustainability is important, but also country-specific regulatory and economic drivers. That to come to something to add on this point. There is another question, probably again for Richard, because it's on the tool SURE. Regarding the SURE tool, does it take into account the different impacts caused by each remediation method? For example, CO2 emissions, water consumption, electrical usage. The user can input different weights, but do you think that particular and more precise KPIs for each remediation method would be also useful?
Okay, SURE is designed as a semi-quantitative tool. In other words, you're scoring, I should say, options on a proportional basis. Whilst it doesn't, you don't sort of put in how many carbon emissions as such, there is nothing to stop you. What you could do in that respect, if you had that information to hand, for example, in the case study with ISCO, excavation and MNN, you were able to actually have those carbon emissions to hand. You could then take those scores, whatever they are, 1 to 5, and apportion those according to the relative impacts. The same with electrical usage. If you've got power supply, you can then apportion the scores. I take the point of what it's saying. It's great when you've got that information because you can make that decision. But if you look at the indicators, there are not that high a proportion when you can actually give quantitative information. A lot of the social economic ones, for example, related to residents' concerns, or whether the development question is going to bring intergenerational equity, or all these sorts of things. They don't lend themselves to quantitative quantitative inputs. So you're better as using a sort of a semi-quantitative scoring, so that you are consistent throughout the entire model. So you're not bringing in bias, say, towards the environmental side by having a more intricate view on things as opposed to social economic. So that's basically the response to that. So no, you can't put in actually directly into the carbon input, but what you can do is then use that to apportion your scoring appropriately.
Thank you very much. Perhaps I will have another questions. Is there a guideline to follow as for the relative percentage of weightings to be assigned to indicators with reference to the overall percentage for environment, economy, and society? Perhaps Richard again.
Yeah, in terms of guidance, well, it again sure allows you to be able to weight what you like, and I think this is obviously an issue that's going to be, as somebody has put, I think, in the chat, I mean, is very much country specific. I mean, we will be putting in the ability to be able to weight the domains in the final version on an equal footing. So in other words, you weight environment, society, and economy overall, and that weighting is pushed down. In terms of the guidance for that, and again, it comes back to the consultant's professional judgment, and in terms of the indicators, again, in discussion with the stakeholders, and the stakeholders are then have then got the ability to go back and question those if their interpretation has not been done properly, or if they disagree. So in terms of formal guidance, I mean, there's a lot out there, not in actually show itself, but I mean, if you go back to the SURF UK guidance, for example, you know, there is quite a lot in the 2020 revised guidance that gives some really good pointers there. You know, in terms of sustainability in general, as far as the weightings, but each of the weightings are really sort of site specific, project specific, you know, and, you know, should be adhered. If you adhere to the sort of the, you know, ISO standard guidance, then it enables you to really, you know, involve people in that decision-making process to input appropriately, I think.
Okay, and another questions is arrived in the chat. Have you think to insert special maps link, for example, land use vicinity with inhabited areas in your tool, or maybe air emissions factor for the industry from the EU guidelines, and you can have a direct evaluation when it's possible? Probably Richard again.
The answer to that is no, we haven't. But obviously, we want to get SURE established first, so that everybody is happy with it. This is going to be the first. When we launch this, this will be the first version. We want people to be comfortable in using it. We want it to be accepted. We want it to be, you know, used on a simple basis. But going forward, you know, there's nothing stopping us, you know, in further versions of this, being able to, you know, add in appropriate models, appropriate maps, appropriate linkages, if these are, you know, appropriate to the overall sustainability assessment process. So it's not, I'd say not at this stage, but in future versions, maybe we something certainly for us to look at.
Yeah, in the chat there is a remark, as Richard has mentioned, SURF UK provides further guidance on many issues such as framing a project, stakeholder liaison, selecting and assessing indicators that could help carry out an assessment using SURE or another tools. I would like to ask another questions. I was very impressed about the presentations of the evaluations linked with the SDGs. You show some very beautiful and interesting evaluation for the three methods linked to the SDGs. And could you perhaps precise how is it defined in SURE, the linkage with the UN SDG objectives? How do you make this linkage?
Okay, well, that is based on the work of, as I mentioned again, we owe a lot, obviously, to SURF UK, and in their guidance, they have actually identified linkages. I mean, Jana and myself were actually active in reviewing some of this guidance, and you know, we basically you know, built it upon that. But SURE does actually do that summation, if you like, of the various linkages that that SURF UK has identified. So SURF UK has said, we've got a linkage here, for example, with climate are the obvious examples, or we've got one here with land for food production. What we've taken really is to look at all the indicators that's actually been selected for the particular project. We've summated, we've added up all the various linkages that those are doing, and that is then reflected in the in the performance of the particular option against those indicators, and that performance is reflected in the relative contribution to fulfilling that particular UN indicator, that particular SDG. So it's based on SURF UK, but what we've done is to basically take what SURF UK have done and package it up into this model.
Okay, thank you very much. Questions. So the first, perhaps a remark in the chat that there are publicly available footprinting tools for technologies such as the US tool Sitewise that can help quantify various consumptive indicators. And there is a new question. So your SDG scores are additive. There is no weighting or apportionment.
Yeah, that is good. I mean, you don't directly go in there and weight them as you do for the indicators themselves. It is based. It comes back to SURF UK's linkages that they've established, and it is essentially taking those and looking at them through SURE itself. It's not there's not a sort of direct scoring of the indicators as such within the tool.
Thank you very much. I haven't read all the thank you and the congratulations for the great session in the chat, but yes, the speakers and the presentations were very appreciated. So I would like to ask one last time if there are some more questions in the public. No, only thanks and congratulations. I would like to ask Aldo if you have questions or remarks before we let the floor to Mark Nilsson for the conclusion.
Okay, thank you, Christian. No, I do not have any further remarks or questions. So I think that we can go with the closing remarks from Mark Nilsson, our global responsible for site solutions. So Mark, thank you.
All right, and thank you to everyone, to our presenters and participants. Appreciate the questions and answer session, and we do appreciate everyone's participation and engagement. We certainly take these questions back as we refine our SURE tool, our documentation. As Richard and Jarno mentioned, we're in sort of the beta testing phase. We're trying it out on projects. This is essentially version 2.0 as we roll it out as a web-based tool. So stay tuned for the the full public rollout and access to use that. And as suggested through our chat and discussions, we should anticipate that our clients, our regulatory agencies, and stakeholders will increasingly be interested in seeing a more formal evaluation of sustainability and I expect resiliency in light of climate change as we evaluate our site remediation projects. And that can be qualitative, semi-quantitative as we're building in the SURE tool, or fully quantitative, some of the tools that Jarno mentioned. And as environmental consultants, experts in the field, we should be prepared to do that for our clients and the public. We expect climate change impacts on remediation as an emerging area of concern and should be prepared to deal with the uncertainty around those conditions, forecast our ability to plan for the future and use of our sites through the effective life of the project. And incorporating these steps of climate resiliency and the remedy assessment early in the planning process certainly can aid in preparing for the future and reducing such uncertainties. So, in closing, we hope that the workshop provided you with a better understanding of how sustainability goals apply to contaminated land and the key metrics for assessing sustainability. We hope you found that Shore by Ramble will be a useful guide to conducting and communicating those comparative analyses for competing options. Certainly, the key questions, we're concerned about, and I think we're working to make sure we address that, as this is not a cover for less costly remedies, but that the remedies are inherently protective, and we're looking for the best one of those options, and be able to share that with stakeholders, clients, and to get their perspectives and guide this decision and discussion of sustainability and what the most important metrics are for a given project. So we get the input from all the stakeholders. And certainly through this tool, we can identify those metrics that have the most significant influence on the outcome of a remedy decision. So, and from those findings, you could actually do more quantitative analysis. To that end, we do invite you to contact us if you'd like more information on the Shore tool, and we look forward to the rollout of the web-based tool later this year. So thank you. Thanks again to all the participants and speakers.
So thank you very much to all for
Thank
the
you to all.
participation. Really, thank you, Christian.
Thank you, Aldo. It was a pleasure to co-chair this session, this very interesting session with you.
Thank you.